The amygdala is an almond-shaped structure in the temporal lobe of the brain, dedicated to detecting the emotional significance of stimuli. Imagine it as a hypersensitive alarm system installed millions of years ago when our ancestors lived among predators. It is located deep in the brain, in the limbic system, the oldest part that formed long before the development of rational thinking. How this ancient mechanism works. The amygdala is activated by fearful stimuli, including scary faces, fear-inducing images, and conditioned fear signals. The process happens lightning fast, in fractions of a second. When your eyes or ears receive a signal, information travels two paths: the slow one to the cerebral cortex, where conscious thinking forms, and the fast one directly to the amygdala. This fast path is an evolutionary advantage. If something moves in the bushes, it's better to jump first and think later, whether it was wind or a tiger. The amygdala can tell your body to panic, which is good if you really need to panic. But this reaction isn't as useful if you panic in a situation that won't harm you. For example, public speaking. The mechanics of this process resemble an ancient watchtower. The amygdala receives information immediately from several sources, from the senses through the thalamus, from the hippocampus with its memories, from other brain regions. It compares the received data with the threat archive, memories of past dangers and innate fears. If it finds a match or even similarity, it immediately activates survival mode. The mechanics of fear from within. The amygdala identifies and regulates emotions, stores memories, and attaches these memories to specific emotions. It also activates the fight-or-flight response. When the amygdala identifies a threat, it instantly triggers a cascade of reactions. First, it activates the hypothalamus, which controls the hormonal system. That in turn sends a signal to the adrenal glands, which release adrenaline and cortisol into the blood. Simultaneously, the amygdala sends signals throughout the body. The heart speeds up to pump more blood to muscles, breathing becomes more frequent for better oxygen saturation, pupils dilate for better vision, digestion stops, now is not the time to eat, the immune system is suppressed, energy is needed for escape. Why it doesn't distinguish real from imaginary. After several pairings, the tone by itself elicits a fear response, freezing in place, heart rate acceleration, and stress hormone release. The amygdala is critically important for forming and storing this association. Here's the key. The amygdala works on associations and doesn't analyze context. If you once received an unpleasant email from your boss, the amygdala remembers notification sound equals danger. And now every notification triggers the same reaction, regardless of content. The amygdala evolved in times when threats were concrete and physical. A lion or snake is a real here and now danger. But modern threats are abstract. What if I get fired in a year? The amygdala doesn't understand the difference between a lion is running now and maybe there will be a problem in a year. For it, both scenarios are equally real threats requiring immediate mobilization. The paradox is that the amygdala cannot distinguish real danger from imagined. A vivid memory, an anxious thought about the future, a horror movie, or even an intense conversation can trigger the same physiological reaction as a real-life threat. For it, a memory of a dog that once bit and a dog approaching now are identical alarm signals. Emotional memory and conditioned reflexes. The main conclusion of fear research is that the amygdala plays a critical role in linking external stimuli to defensive reactions. The amygdala creates powerful emotional memories, especially those related to fear. These memories are stored at a very deep level and can be activated involuntarily. That's why a person who survived a car accident can panic at the sound of brakes, even when they know they're safe now. Amygdala hijack, when the guardian takes control. Sometimes the amygdala reacts so quickly and powerfully that it literally hijacks control from you. This reaction can help people in immediate physical danger react quickly for their safety. In such moments, you might scream, cry, attack, or flee before consciousness has time to analyze the situation. Later you think, why did I act that way? It was illogical. The positive side and modern challenges. Although historically the amygdala was considered to participate mainly in fear and other emotions related to unpleasant stimuli, it's now known that it participates in positive emotions caused by pleasant stimuli. The amygdala also responds to joy, excitement, surprise. It's not broken. It works exactly as it was programmed by evolution. The problem is that the modern environment is fundamentally different from what it was created for. In primitive society, calm followed danger. The lion either retreated or, well, then there were no stress problems. Today, threats are continuous. News, bills, deadlines, social media. The amygdala doesn't have time to turn off because danger signals come constantly. The result is chronic activation of a system designed for short bursts. This knowledge gives us power. Understanding the nature of the amygdala, we can learn not to be slaves to its reactions. When we feel fear or anxiety, it's worth asking ourselves, is there really danger now, or is it just the ancient guard reacting to shadows? Mindfulness practice allows us to create a pause between the alarm signal and our reaction. In this pause lies our freedom. True wisdom lies not in suppressing the amygdala, it's needed for our survival, but in learning to cooperate with it. Acknowledge its signals, thank it for vigilance, but don't let it control our lives. For whoever masters their own reactions, masters their own destiny.